Hi, my name is Chie Funatagawa. I am the Field Applications Scientist Manager for North America here at Unchained Labs. We're so happy that you were able to join us today for this live demo of Big Tuna. During the session today, well, towards the end of today's session today, we have a Q&A session. Please feel free to put in any questions that you may have during today's live demo. All you have to do is click on the Q&A button on your Zoom navigation bar. It should be located either on the bottom or the top of your screen. When you are submitting your Q&A, please avoid submitting it anonymously if you can. We would like to make sure that we can reach out to you via email, just in case we can't get to your questions during the live session today. However, during the live session, we do want to make sure that we can get to as many questions as possible. So let those questions come. All right, with that, I would like to introduce Delray Jackson. He is our Senior Product Manager of Buffer Exchange here at Unchained Labs. Hi, Del.
Hi, Chie. How are you?
I'm doing all right. It's like we coordinated today.
Oh, yeah. I love your taste in clothing.
It looks nice. Looks good on you. So what are we going to see today?
We're going to see how easy it is to buffer exchange and concentrate your biologics like proteins or monoclonal antibodies, or maybe some gene therapy biomolecules like AAVs and LNPs. We're going to see how you can do all that easily on Big Tuna, get a quick overview of the hardware, in-depth look at the software, and then we're going to see it all in action.
Awesome. That sounds really good. I'm excited. Are you ready to put on your show?
Yes, as long as I just make sure I know where to put my hands, I think I'll be okay.
We talk with our hands,
yeah.
don't we? All right. All right. Well, I will let you get started. I will make sure I monitor the Q&A from our audience to make sure I can answer them at the end of the session today then.
That's great. Thank you, Chie.
Awesome. Have fun.
All right. Hi. If you've tuned in, you probably are very familiar with the problems from doing manual buffer exchanges and concentration. Also, you know how critical it is for many of your biologics and gene therapy workflows. That is exactly why we created this beautiful instrument behind me, Big Tuna. So today, we're going to see how Big Tuna not only saves you time, but also gives you high sample recovery for doing your buffer exchanges and concentrations. And then there's a few other details that we sprinkled in throughout the way. Before we jump into the instrument, I want to show you where the buffer exchange magic happens, and it all starts right here in our unfilters. They come in two formats, a 96 well and a 24 well. The working volume range on the 96, as you can guess, is smaller. It's between 100 and 450 microliters. On the 24 unfilter, you can go from 450 microliters all the way up to 8 mils. Both of them use regenerated cellulose as their membrane material. It comes in a molecular weight cutoff range between 3 kilodalton all the way up to 100 kilodaltons. We've designed and manufactured these unfilters specifically to withstand the pressures that we use in our UFDF technology on the Big Tuna. So speaking of, let's take a look at that right now. You should have a nice overhead view of the Big Tuna deck. And on the left of your screen or front of the instrument is the buffer exchange chamber. That's where all of the magic happens. In there, we will apply even positive pressure at 15, 30, or 60 PSI across all of the samples in your unfilter. Chie has lovingly loaded it in there, so you can't see another cool piece underneath, which is an orbital mixer. The orbital mixer can optionally run during your buffer exchange cycles to give you even more even flow and consistent results across, again, every single sample in the unfilter. Another cool piece is this right here. That is the ultrasonic volume sensor. Big Tuna uses that at the beginning of the run and then with every buffer exchange cycle to get an exact measurement of the volume of each of your samples. That information is critical because it tells Big Tuna the flow rates, so how fast your samples are flowing. And that information gives an exact feedback to Big Tuna to be able to add the buffer remaining in doing your buffer exchanges. You can see that on deck, you have 8 positions to load buffer reagent reservoirs. You can use a variety of styles. We've shown a few here for you. And what we'll see later in action is that the 6-tip channels, 6-tip arm on the left side of Big Tuna is going to add that exact amount calculated by the ultrasonic volume sensor at the end of your buffer exchange cycles. Something else that you might see is that there's an on-deck tip station and a tip hotel here on the right of the instrument or the bottom of your screen. And this is another key piece that gives you that walk away time that you're going to enjoy with Big Tuna, and that Big Tuna is going to automatically move those tips from the hotel to the on-deck as needed. So with that quick overview of the hardware, I want to show you something I especially love, which is software. Yes, you can probably guess I'm a very big fan of software. And so let me just share my screen for you. And here's Big Tuna software. This is what everyone in your lab is going to be able to use to run their buffer exchange and concentration experiments. Right away, you'll see that you have 4 options available to you. One is you can look at already designed experiments, create a new one, which we'll do in just a moment. Also, a nice time savings is that you can create templates of your common buffer exchange and concentration applications and have those ready to go from create from template. And then finally, the results. You're going to get detailed results with every run that you do. Before we jump in, I want to show you something else since you took the time to tune in to our special live demo. It's questions I get asked on a regular basis. One is, do we have user management? Yes, we do. So you can set up different permission levels for people in your lab who are using Big Tuna. Big Tuna is an automated solution, so we also get asked, can we add it into our, integrate it into either our upstream or downstream automation that might already exist? The answer is yes. One key piece of that is the API, which is written to the CELA standard. So Big Tuna software does have an API, lets you do neat things like connect it directly to your limbs, do remote monitoring, and even remote execution. Let's jump right in to create a new experiment. And something that hopefully comes across from the screen that you're looking at is that you're not programming automation. All you really need to know are details about your biomolecules and your buffer exchange parameters, and you're ready to go. The nice breadcrumb trail at top is going to guide everyone in your lab to set up their own buffer exchange and concentration experiments. And so let's take a look at that right now. First step is experiment name. Chie, do you have an idea for what we should call today's experiment?
I want sushi.
Don't we all? Perfect, thank you. Here you can see those different applications that we talked about. Buffer exchange with the option to concentrate. You can also just concentrate samples if that's needed. And a relatively new application we've released with Big Tuna is reduced sample volume. This is a concentration application that runs with our unfiltered 24, but instead of being limited to a starting volume of 8 mils, you can place even more volume of sample on deck and concentrate all of that down. So there, we'll click next. And here we get to our reagents. Again, all you have to enter in is what you know about your biomolecules. In this case, your samples on the left and your buffers on the right. You can add samples manually, but since I get a little nervous in front of you, I don't want to take time to try to enter all of those. So I'm going to show off another nice feature, which is that you can import already made sample lists from a local file, from anywhere on your network drive, or with the API directly from your limbs. Here you can see the details that you'll get. We have sample names, sample concentration, and then some optional information such as that you might want to put in there, which will filter through to your reports. Get it? Filter through. It'll end up on your reports, which could be your sample starting buffer and any notes that you might have. Optionally, you can also enter the wells that are where your samples are going to go on the unfiltered. That can save a little bit of time, but as we'll see in the next screen, it's also super easy to just do that manually as well. I'd like to point out the sample units here. We said that Big Tuna is compatible. It's really great for proteins, monoclonal antibodies, AAVs. So you can make sure that your sample concentration units make sense, in those reports that you're going to get. Very quickly, we'll add buffers. And one thing I want to point out is that Big Tuna software validates every step of the way. So I wasn't able to click next until I had filled out everything on the screen. Again, making sure every run that your lab operators that you set up on Big Tuna is validated and going to run successfully. Nice, beautiful color screen here. The colors indicate which samples are in which wells of the unfilter, and that was done because we used the optional ability to enter in the well ID on the previous screen. But to show you how easy it is, you can either select rows or columns to enter your samples or buffers. You can also select individual wells. Once you do that, you just click and drag. And in this case, it's a good demonstration of how you might set up, for instance, a formulation study. Maybe you want to see, you've prepared different proteins, different nucleic acids. You want to see what, maybe measure downstream what their compatibility or stability would be. And so you can set it up nice and easy there. If you made a mistake, it's pretty simple with one of these buttons here to clear your sample, buffers, or both. Here, you can see that you can set up the reservoirs. And I really like this screen because it shows off that again, you're not programming automation. So you just enter in your samples, your buffers. Big Tuna is going to say, hey, here's the number and the type of reservoirs that you need, but we don't take away that flexibility. So if you need to, you can enter that yourself. And I just realized that due to live TV, I actually selected a reduced sample volume, but no problem. I can go back, fix that, and then get us right back on track. Here, this is really all you have to enter is the information about your samples. But you don't have to be an expert on buffer exchange. Big Tuna is the expert. You can even use our sample presets where you can select AAVs or LNPs. What that does is change the critical parameters that will let you run successfully. Things like target removal per cycle, so you can have a lot flow out in every exchange cycle or less, the pressure level, and the mixing speed. And these are all recommended starting points. You can go back and customize them at any time that you want. So really, we just have to enter in what our starting volume is. And notice how, again, Big Tuna guides everyone in the lab to be able to set up their run successfully. So I get that hover text, that nice feedback for me. And running a concentration is as simple as just either setting this, a lower initial volume. So let's say we want to do a 2x here. So we just enter in less volume. And with that, we're able to move forward and get to the prep list, or as GA calls it, the shopping list. And we call it that because it shows everyone in the lab when they set up their runs exactly what they need and how to prepare it. So in the case of the unfilter, you'll get an unfilter sample list that shows you the volumes of each sample, and then a nice little graphic showing exactly where those go in your unfilter, and you'll get the same in your buffer map as well. You notice here also the tips are calculated at the beginning of the run. How many tips do you have to add? And I just want to point out one thing, so I'll go back to the previous screen here and show you that you can even control whether or not tip reuse is allowed. So we reuse tips up to 12 times, but remember, with the ultrasonic volume sensor, the tips never come into contact with your sample. And so contamination is already reduced there. But if for whatever reason you don't want to reuse tips, you have control over that as well. So we'll go to the next screen. And again, a nice overhead view, probably looks very similar to what we just saw a few moments ago, which is the Big Tuna deck. In the lab, you probably have a lot of lab equipment. And your lab operators, technicians, yourself, you're trained on this, but maybe you might go between different equipment. That's what I really like about Big Tuna software, is it guides you every time. So you don't have to guess, to remember, when or where to load your unfilter or your reservoirs. You're going to get nice, clear, simple graphical feedback showing you exactly the steps that you need to follow to set up your Big Tuna run. Speaking of, let's do that right now. That's always fun, right? Right away, this is running in simulation mode, but you'll see Big Tuna tells you primarily two things. One is like the overall status of your run. So, how many filtration cycles, exchange cycles have you gone through? How many concentration cycles are happening? But another nice feature is you get this sample by sample feedback, or the progress of how that buffer exchange is going for every single sample. That's really nice because, you can set it and forget it on Big Tuna, but at any point you can come back to the status screen here and see where your samples are at. And in some cases, if you have varying concentrations or different starting buffers, your sample flow rates might vary. Some of these samples may, on occasion, finish before others. In that case, you have this nice feature up here. When you pause the experiment, you can select which of the samples you might want to take out, and then let your run continue. And I really have saved the best for last, the report. And unlike any of those manual buffer exchange techniques that you might follow, on the report screen, you're going to get very detailed information. What is that information? Well, let's just scroll down here. On a sample by sample basis, you'll get the starting volume, the final volume, and then based upon that initial concentration that you entered, you'll also get an idea of what that end concentration value is, your sample by sample percent exchange, which can be very useful information within your group, or maybe you want to hand that off downstream after you pass off your exchange samples. It also does diavolumes, which is great, because for me, I can't do that on the spot calculating what that is, but no worries, Big Tuna's got you covered. So speaking of, let me stop share here so we can see exactly how this is captured in real time on Big Tuna. Here the run has already started, and the ultrasonic volume sensor, again, is going back and it's going to measure the initial starting values, starting volumes of your sample across every well. This information is then correlated to what you had entered in the software. So even if you were off a little bit in your volume, no problems. Big Tuna is going to know exactly how much volume is there. Again, prioritizing sample recovery and sample integrity. So you can get all the benefits like that walk away time, set it and forget it with Big Tuna, but it doesn't come at the expense of having to worry about your samples. Your samples are safe with this constant measurement. So on the initial run, the door will close. The buffer exchange chamber will pressurize to whichever PSI setting was input. We're speeding this up for the purposes of television today, but after that filtrate has passed through, Big Tuna then would go back and remeasure the volumes of each one and know exactly how much new buffer to add to it. And this, again, is done by the liquid displaced air pipette channels that we have. There are 6 of them. They have variable Y span, so they work with both the 96 and the 24 unfiltered. And this is going to do the pipetting for you. You don't have to come back and monitor it or look at it. Every single buffer exchange cycle, Big Tuna is going to know exactly how much to aspirate and then how much to dispense on an individual basis into each of your wells. The CVs that you're going to get with this technology, with this pipetting technology, are great because you might have different buffer compositions, might be subtle property changes, viscosity, for instance, but you'll still achieve with Big Tuna a 5% or better CV in the pipetting. So with that, I hope it gave you an insight of what it might be like to have a Big Tuna in your own lab. So I thank you for paying attention. I want to thank everyone behind the camera, Kat and Jeff, who helped us put on this demo. And then, of course, my partner in crime, Chie, who's done the moderation.
Awesome. Thank you so much, Del. That was a fantastic presentation. And I think it really showed how easy this buffer exchanging can be. So I definitely am not trained in automation, and I can tell you that I can use it too.
Awesome.
So.
Good.
Awesome. Well, we do have some questions that have come in, so I'm going to go ahead and answer them. Again,
Okay.
If you guys have any other questions, feel free to, again, use that Q&A button to ask some questions. We will try to answer as many as possible. So I have one question. I can see someone was really paying attention during the parameter setting on your software. Maybe another little software junkie. It says, how is the diluent filter used?
That's a good question. Yeah, I guess I glossed over the details for it. So diluent filter can be used, I would say, in 2 ways. One is to give you perhaps faster results, faster exchanges. So maybe if you have a more viscous sample, maybe it's a higher concentration, you can do that initial dilution with your buffer, and that's going to give you even faster flow through results. Another way that we found using it is with LNP samples, lipid nanoparticles, and that actually the sample integrity values of size changes and encapsulation loss or retention can be maintained by doing an initial dilution up front. So better time and faster and better results.
Awesome. Sounds smart. All right, so I have another question. It says, how many different buffers can be exchanged at a time? Example, if we have 10 samples and need to exchange 10 different buffers, can Big Tuna do that?
Yeah, great question. So definitely, you can have a 1-to-1. So you can have 96 samples, 96 different buffers. or any combination in between. So that's how we often see customers using Big Tuna for formulation studies, is they're sampling. So they might have the same sample across every well in their unfilter, and then they're doing a bunch of different formulations, or the opposite. Maybe they have 96 different samples and they're really just checking one buffer.
Can you go all the way as 96, 96, go all crazy too?
You can go as crazy as you want, Chia.
Awesome. All right, so the next question is, what type of pipette channels are used? I think you might have touched on this, but.
Yeah, so these are liquid displaced air pipetting. So there is system fluid that's used, and that really generates the air gap that's going to aspirate and then ultimately dispense. Your samples, your buffers never come in contact with the system fluid itself. That's just again, used as almost like a piston to give you those really nice results.
Awesome. Let's see. What if I enter the wrong volume in for my sample?
No worries. That volume sensor is great. It's going to measure what you entered. I didn't cover it in the software, but we also have optional error recovery parameters that you can set. And it's pretty straightforward. Either, you can say Big Tuna, just run on whatever I load in there, regardless of the initial volume measurement. Or if there's a discrepancy, pause the run at the beginning of it, which will prompt the operator to come back and address that. But either way, you don't really have to worry about it because we'll always measure that volume. You're not going to risk running out your sample.
Awesome. This question is, can I reuse filters? Can you make buffer mixtures from several working stocks? I think that might be two questions.
So reusing unfilters, you can do what we call a partial run. You cannot reuse a well that you've already run through. We're very careful and meticulous about making sure that the quality of every single unfilter is such that you won't have, a failure of an individual well. But once you use a well, once you hydrate it with, buffer and or sample, it really does change the properties. So you would never be able to reuse a well you've already run through, but you can use part of it. Life doesn't come at us in 96 and 24 samples at a time. We understand that. So what you can do is use part of an unfilter and then use the other part in a subsequent run.
Awesome.
And then what was the question about the buffers?
I think the other one was, let me actually go back to it. It says, can you make buffer mixtures from several working stocks? So I guess, can you have different buffers maybe?
Yes. So Big Tuna will not prepare your buffers for you. That's why often, we have customers who will integrate it into other automation, because if they are doing a bunch of different complex buffer formulations, then they could have upstream, a liquid handler, pass that off. But Big Tuna will really just add buffer from the already prepared buffer from the on-deck reservoirs to your unfiltered.
Awesome. So you kind of touched on this. I'm just going to keep going with the questions. There's a lot of good ones coming in. So it says, why would I pause to remove some samples for a run? I think you touched on that pause experiment.
Yeah, exactly. I like to bring up these features, but then I know sometimes they can bring up other questions. But using pause is completely optional. So it's not necessary to do it. Again, your samples are going to perhaps flow at different rates. Concentration, viscosity, all of those factors can mean that a sample in one well might flow faster or slower than a sample in another. Now, you can just let that happen and Big Tuna will compensate for it. It's an adaptive ultrafiltration technology. What that does mean, though, is that we're always going to modulate the cycle time so that, because Big Tuna prioritizes sample recovery and integrity. And so it essentially normalizes, if you want to think of it this way, to your fastest running sample. And so that means that slower filtering samples will run a little bit slower. So by pausing and taking out samples, your overall buffer exchange or concentration run, the time that it takes to execute that is going to be shortened.
All right. Well, this one is actually a little bit related to that, because it says, how does Big Tuna adapt its buffer exchange cycles?
Yeah, great question. So exactly that. So your PSI value is set at the beginning of the run. It could be 15, 30, or 60 PSI. And then really it's, besides the optional gentle orbital mixing, it's just the amount of time that we're applying that pressure. Mm-hmm. And that's exactly what the feedback cycle of being able to measure the volume enables, which is the amount of time in every single buffer exchange step, if you want to think of it that way, is going to be modulated, either extended or shortened.
I love that, because I know when you exchange buffers at times that will change, the conditions of your sample, right? That's the point of a buffer exchange.
Exactly. Yeah.
So it's good that it's not just standardizing it for the whole run. So I like that. I love the additional follow-up questions to something we answered. It feels like a conversation, so I'm going to ask this one.
Sure
but
thing.
It says, if you pause your experiment, will the Big Tuna refill the empty wells? If not, will there be a problem with pressurization, for example, empty versus?
A lot of attentive and smart attendees. Great question. Yeah. So obviously, you're applying even positive pressure, and the rate of that pressure, as the sum rate or the total flow rate of that through the system is a function of how much resistance it's going to be met by. So very good question. You're right. When you take out sample, that one well is going to flow a little bit quicker. You don't have to worry about it, but for best practices, you could perhaps add like a mixture of glycerol to that to make sure that that one well isn't going to be running faster and messing things up. You don't have to. It's completely optional, but really great question.
There's a question about, is there any sample lost on the membrane or through, I guess, the buffer exchange process?
So complete transparency, we've never done those experiments. We haven't like chopped up a regenerated cellulose membrane and then ran it through mass spec to measure it that way. What we can measure though is our sample concentration beforehand and our sample concentration after. And we have from 96% or greater results. So is significant sample loss to the membrane? No, I would say not. And the reason why we pick regenerated cellulose is across the industry, it's ubiquitous and it's a popular membrane type material because it has low reactivity for charged particles like nucleic acids, proteins, AAVs, and LNPs.
Let's see. There's one question that says about target exchange percent. So I'll say, would you recommend to play around with settings like target exchange per cycle to reduce stress on proteins?
Oh, yes, definitely. Yeah, you'll like that. So oftentimes with Big Tuna, we have some customers who are, maybe they have like a standardized upstream manufacturing process, and they really want to tweak or hone their buffer exchange parameters for that. So yeah, our preset values are collected from, feedback that we get by doing many different types of sample runs for both customers and for internal validation. And so those are really just like best starting points for it. But you have complete power to go back and tweak it. And you're right. The total exchange percentage combined with that, how much you want to take out per cycle can often be perfected, if you will, to give you even better results.
So I really like this question because I think it highlights one of our cool features as I'm clearly telling you what it is with my hand. So it's talking about how does it deal with clogging of filters. So it's really more like, I would think, avoiding that, but.
Yeah. So one, with other techniques, you can get what's referred to as dead end filtration. And so, as you concentrate your samples down, so maybe you're running them in like a spin column, they are going to, as you reduce the volume, your concentration increases, right? There's less volume there, but the same amount of molecules of interest. And so by the gentle orbital mixing, we keep that in solution more. And so we don't see dead end filtration, which can lead to clogging with Big Tuna.
That's awesome. All right. Well, that is probably about as much time we have for today.
Oh, I was having so much fun.
It was fun. So thank you so much, Del, for the walkthrough, for an awesome demo, and also for answering all those questions. And thank you for everyone that asked all the questions. Yes. So thank you, everyone who joined today. Again, if you would like to continue to have a deeper conversation, please don't hesitate to get in touch with us either through our website or you can email info@unchainedlabs.com. Our team would love to connect with you, continue to talk about the Big Tuna in more depth. So thank you again for attending our live demo. I hope you guys have the wonderful rest of your day. All right. Thanks, everyone.